So in this series of tutorials, we are learning how to normalize relations to eliminate problems arising from update, insert, and delete anomalies. And as an example, we took this employee projects relation, which was in first normal form. We inspected that one table and saw that it has these anomalies, and we took it from first normal form to second normal form to try and get rid of those update, insert, and delete anomalies. And we did that based on the functional dependencies that were there in that table. And we ended up with these three relations, okay? And each of these three relations is in second normal form. You can go back to the tutorial and see what the definition is of second normal form. But now the question we are asking ourselves is, okay, now that we have gotten these relations into second normal form, have we eliminated those three types of anomalies? Now, if you look at the employee table, we haven't done so. Let's take a little more detailed look. In the employee table, if the hourly rate of a database designer changes from $105 to $150, then I have to change it here once and I have to change it here twice. Okay, so unless I change it in both places, I will have inconsistent information in the table. So I have an update anomaly. Similarly, if Smithfield, if you take employee Smithfield, if Smithfield leaves the company, then I delete Smithfield, but as soon as that happens, I also lose the information that the hourly rate of a programmer is $35.75. Why? Because Smithfield is the only programmer in this set, okay? So if I delete Smithfield, I also lose the corresponding information that a programmer's hourly rate is $35.75. So this is a deletion anomaly, meaning I really want to delete only the employee, but in the process, I'm also deleting associated information that I really don't want to delete. I do not also want to delete the information that the hourly rate of a programmer is 35.75. Okay, so we have an update anomaly, we have a delete anomaly, and we have an insertion anomaly as well. Suppose I want to add a job class, let's say program manager. So you can look at the job class column and you can see that there is no job class called program manager. Let's say the company says, okay, we will have a new category of job. It's a program manager and the hourly rate is $250 an hour. So I just want to record that information, but I cannot. So let's say I just say program manager, and the hourly rate is, let's say, $250 an hour. So I cannot add this information in the database until at least one employee has been hired who is a program manager. So I have an insertion anomaly. All right. So the bottom line is, even though I have gotten the relations to second normal form, you don't always eliminate update, insert, and delete anomaly by staying at second normal form. So once in a while, we will have to go to a higher normal form, which is called third normal form. Okay. So the question is, why did this update, insert, and delete anomaly arise in this employee table? Okay. And the reason this arose is because of what is called this transitive dependency. All right. If you go back and look at the functional dependencies that were there in the original table, you will find that employee number determines job class, employee number determines charge hours, and job class also determines charge hours. Okay. So you have this transitive dependency. Employee number determines job class and job class determines charge hours. So what is a transitive dependency? Okay, so if A is taller than B and B is taller than C, then of course A is taller than C. Similarly, if A is heavier than B and B is heavier than C, then A is heavier than C. So the relationship heavier than, taller than, these are transitive. Okay, so we have a transitive functional dependency in the employee table that we are looking at. So employee numbers is the primary key. So employee number determines last name, employee number determines job class, employee number determines hourly charge. That's for sure, because employee number is the primary key. However, job class also determines charge hour. Okay, so the situation that we have here is a transitive dependency, that is employee number determines job class determines charge hours, and that is why employee number determines charge hours. So the reason, you can easily see now, if you have a transitive dependency like this, then let's say there are 4 employees, and of those 4 employees 2 are of the same job class, then this information, the hourly rate, will show up multiple times. So anytime you have a transitive functional dependency, you're going to have redundancy in the table, and as soon as you have redundancy, you're going to have the update, insert, and delete anomalies. So the source of the problem in the employee table is this transitive dependency from employee number to job class to charge hour. Okay, so the next step that we need to do is to take this relationship to third normal form, and going to third normal form removes the transitive dependency. So we ask ourselves the question is that, is the relationship in third normal form? And here is the definition. Again, you cannot skip steps. A relation is in third normal form when it is in second normal. So it first of all has to be in second normal form. So you cannot go directly from first to third. You have to go from first normal form to second normal form. So first make sure that the relation is in second normal form, and then make sure that there is no transitive functional dependency. Okay, so in a third normal form relation, there are no functional dependencies. So let's look at our employee table. In the employee table, the employee number is the primary key. Therefore, so you can go back and look at that table here. So employee number determines last name, it determines job class, and it determines charge, hourly charge. Okay, so that's what we have written over here in the functional dependency. That's if I know employee number, since it's the primary key, I also know employee last name, job class, and charge hour. However, I also know that job class determines charge hour, hourly charge. Okay, so I also know that job class determines charge hour. So that's how you have a transitive relationship from here to here, and then here to here. So A to B, B to C, and that's how you got the relationship between A to C. So there is an indirect sort of intermediate relationship going on. Okay, so this is the transitive relationship that is causing the problem. Job class is a non-key attribute, and that is determining charge hour. So here's the problem. The problem lies in the transitive dependency. So in third, when you go from second to third normal form, you have to split the table to remove transitive dependency. Okay, so let's see how that is done. Again, okay, so how do we, so here's the table we will need to split. There are no transitive dependencies in the project table. There are no transitive dependencies in the assignment, in the hours table. So this first table and the second table, they do not have any transitive dependencies. So they are not only in second normal form, they are also in third normal form. This is also in third normal form. This employee table is in second normal form, but it is not in third normal form. Okay, because of this transitive dependency from here to here and from here to here. Okay, so we have to split the employee table to get rid of this transitive dependency. So let's see how one would go about doing that. So just to show you the end result of the split, so we had that, here's the original employee table. We had 1, 2, 3, 4 columns. So what we do is take this functional dependency, which is the transitive piece, and just pull it out. Okay, just pull it out into a fresh table. Do you see over here, we have taken job class and hourly charge and pulled it out into a fresh table and left the rest of the employee table over here. So the employee table has now been broken up into 2 tables, and now you can see that each of these is in third normal form. there are no transitive dependencies either in this table or in this table. Okay, and we had previously said that the project table and the hours work table, these do not have transitive dependencies anyway, so they are already in third normal form. So now we started with an original table which was in first normal form, had all kinds of anomalies, and now we have split it up into 4 tables that each of which is in third normal form. But notice how the split was done for the employees. We did the split in such a way that we can combine these 2 tables back together again. So do you see that even though I pulled out job class and hourly charge, the job class remains in the employee table as a foreign key, so that I can connect these 2 tables back together again. So the general process of removing the third normal, of removing transitive dependencies to get a relation in third normal form, okay, is given over here. Okay, as we have to make new tables to eliminate the transitive dependencies. So we write its determinant as a primary key for a new table. So if we have A determines B determines C, we have a transitive dependency like this. We take this transitive piece and pull it out into a new table, and then whatever remains, we keep it back in the original table. Okay, so we split the 2. All right, so that's sort of the informal description of how we break up a table that's in third normal form, that's in second normal form, into third normal form to remove transitive dependencies. So the end result of all of this, remember, we had one big table called project, and we had all the attributes. Okay, we had all the attributes here, and this was in first normal form. And then we said, okay, this table has insert, update, and delete anomalies, and we progressively started splitting the table to get better and better tables which don't have any anomalies. So we went from first normal form to second normal form, and then to third normal form. So at the end of the story, when you're done with normalization, and at each step we were splitting the tables, right, to get to higher and higher normal forms. So at the end of the process, the collection of relations that you get from that one table where you started, each of them, this is very important, each of them must be in third normal form. So we started with that one table and we ended up with 1, 2, 3, 4. We ended up with 4 tables, and if you look at each one of those 4, you will find that each of them is in third normal form. So if you look at the project table here, I don't need to draw the table. I can just look at the names over here. You can see that project name depends on project number, right? So there are no partial dependencies. Why? Because the primary key just consists of one attribute, so there cannot be any partial dependency. And so you also don't have transitive dependency. You don't have a situation where A determines B and B determines C. So there are no transitive dependencies. So project is in third normal form. Similarly, if you look at rate, the table called rate, it's in second normal form because job class determines charge per hour. There is no partial dependency here because the primary key is not composite. And again, there are no transitive dependencies. You don't have a dependency that looks like this. Okay, so this is also in third. This is third normal form. This is also in third normal form. Okay, now when I look at hours worked, the assignment, the primary key is composite. It's project number plus employee number, but the hours worked depends on both of these attributes. Okay, so it doesn't depend on a part of the primary key. So this is in second normal form, and you also don't have a transitive dependency here. You don't have a situation where A determines B and B determines C. So this third relation is also in third normal form. And if you examine this fourth one, the employee, same story, it is in third normal form because there are no partial dependencies and there are no transitive dependencies. So this process of progressively splitting a table, we start from one big table, which is in first normal form, and we gradually get it to third normal form. So you want to end up with a collection of tables, each of which is in third normal form. Now, in practice, getting to third normal form is almost always enough to get a collection of tables that have no anomalies, all right? But just be aware that there are some very unusual situations where even when you get relations into third normal form, you still end up with some anomalies, update, insert, and delete anomalies. And in those rare instances, you have to go to even higher normal forms like fourth normal form and Boyce scored normal form BCNF, but we will not be studying those in this course. For purposes of this introductory course, as long as you know how to normalize tables up to third normal form, that will be sufficient. So this is where we will stop in terms of theory for normalization. And in the next video, I will actually work through a complete example and show you start to finish how to examine the table for anomalies and how to keep splitting it down and to get a collection of relations that are in third normal form and which will not have the anomalies that were troubling the first original table.